Hello everyone, I am Mrs. Suchita Malpe and I am starting today chemistry part of our syllabus. But before that, let us read out today's thought. Rise up, start fresh, see the bright opportunity in each new day. So, with this beautiful thought, let's get started with lesson number 5, acids, bases, and salts. We are using acids in our day to day life. Lemons and oranges, they contain citric acid. Vinegar is 5% by mass acetic acid. Fertilizers contain phosphoric acid. Milk contains lactic acid. Here are the uses of acids. Acetic acid is also called as vinegar. Citric acid is present in lemons, limes, and oranges. Vitamin C, which is also called as ascorbic acid, and that is needed by our body to function well. Sulfuric acid is used in production of fertilizers, steel, paints and plastics. Examples of acids: hydrochloric acid, sulfuric acid, nitric acid. Hydrochloric acid has the molecular formula HCl. H2SO4 is the molecular formula of sulfuric acid and HNO3 is the molecular formula of nitric acid. Examples of alkalis: sodium hydroxide NaOH, potassium hydroxide KOH, sodium bicarbonate NaHCO3, and sodium bicarbonate is also called as खाने का सोडा है ना, and sodium carbonate Na2CO3, that is called as washing soda. Magnesium oxide MgO, and when magnesium oxide dissolves in water, magnesium hydroxide is formed and that is alkali. Ammonia solution, ammonium hydroxide NH4OH. Sodium bicarbonate is also called as baking soda NaHCO3. Sodium bicarbonate is also called as baking soda. Soap is a mild base. Oven cleaner, drain cleaner, toothpaste, bleach, they all contain bases. Ammonia sometimes found in hair products or cleaning products. Washing powder, sodium carbonate. So these are all examples of alkali. Common salts used in our day-to-day life. Sodium chloride, commonly known as table salt. It is also used in seasoning food. It is also used in making of soap and in the preservation of food. Sodium bicarbonate NaHCO3, it is used in baking powder, fire extinguishers and in medicine as antacid. Children, you might have uh, experienced acidity. Sometimes, maybe the person who is suffering from acidity, uh, that person that person's stomach produces dilute acid which helps in digestion. Actually, our stomach produces dilute acid which helps in digestion of food that we eat. When the production of acid is more than the required amount, we suffer from acidity which causes burning sensation of stomach. In order to cure burning sensation of the stomach, People use basic substances called antacids, and these antacids neutralizes the excess acid which is present in our stomach, right? Before we brush our teeth, the pH of saliva is less than 7, that is acidic. Therefore, the presence of an alkaline substance in a toothpaste neutralizes the acid produced in the mouth and it prevents tooth decay. So, have you understood the importance of acid, bases, and salts in our everyday life? So, we are going to learn more about these substances, acids, bases, and salts in this chapter. Clear to you all? How are the following substances classified into three groups with the help of litmus? Have you understood the question? How will you classify how the substances are classified into three groups with the help of litmus paper? Uh, Litmus paper, if you take blue litmus paper and if it is put up in acid, then blue litmus paper will turn into red color. And if red litmus paper is dipped into a basic solution, then red litmus paper will turn blue, and neutral substances will not show any effect on litmus paper. So blue will remain as blue and red will remain as red in color in neutral substances. Now you have to classify these uh, given substances into three groups, whether it is a acid or base or salt. Lemon, tamarind, buttermilk, vinegar, orange, milk, tomato, alum are acidic substances. Baking soda, lime, milk of magnesia are basic substances, and water is neutral substance. So thus we have divided substances into three categories: acidic substances, basic substances, and neutral substances. In acidic solution, blue litmus paper turns red. In basic solution, red litmus paper turns blue, and neutral solution will not have any effect on litmus paper. Means blue will remain blue, and red litmus paper will remain red. Here, this chart shows name of compound, its molecular formula, and now we have to write down here basic radical, acidic radical, and the type of compound. So let us start. Hydrochloric acid, it has molecular formula HCl. H plus is the basic radical and Cl minus is the acidic radical, and type of compound is acid. Now you have to write the name of the compound, HNO3. So what will be the name of this compound? Nitric acid. Nitric acid contains H plus as a basic radical, NO3 minus as a acidic radical, and it comes under the compound type acid. Now HBr is hydrobromic acid. Basic radical H plus, acidic radical Br minus, and it is an acid. H2SO4 sulfuric acid, H plus is basic radical, SO4 2 minus is acidic radical, and it is an acid. H3BO3 boric acid, H plus basic radical, BO3 3 minus is a acidic radical, and it is acid. So likewise you have to write down the name of the compound, basic radical, acidic radical, and identify the type of compound. The answer of this chart is shown on next slide. Let us see. NaOH, sodium hydroxide. Na plus is basic radical, OH minus is acidic radical and it's a base. Potassium hydroxide KOH, K plus is a basic radical and OH minus is acidic radical and it's a base. Cations are basic radical and anions are acidic radical. Cations are positively charged radicals and anions are negatively charged radical. Cations are basic in nature, anions are acidic in nature. Calcium hydroxide Ca2 plus basic radical, OH minus acidic radical and it is a base. Ammonium hydroxide NH4OH, NH4 plus basic radical, OH minus acidic radical and it is a base. Sodium chloride NaCl, Na plus basic radical, Cl minus acidic radical and it is a salt. Calcium nitrate CaNO3 by 2, Ca2 plus basic radical, NO3 1 minus acidic radical and it is a salt. Potassium sulfate K2SO4, K plus basic radical, SO4 2 minus acidic radical and it is a salt. Calcium chloride CaCl2, Ca2 plus basic radical, Cl minus acidic radical and it is a salt. Ammonium sulfate NH4 by 2SO4, NH4 plus ammonium ion basic radical and SO4 2 minus is the acidic radical and ammonium sulfate is a salt. So children, have you observed one thing, that the substance acid contains H plus as a basic radical and the substance base contains acidic radical OH minus. So can we define acid? Now it is very clear from this chart that a substance which on dissolving in water gives rise to H ion as the only cation, then it is called as an acid. Let me repeat one more time. A substance which on dissolving in water gives rise to H plus ion as the only cation, then it is called as an acid. And what will be the definition of base? A substance which on dissolving in water gives rise to OH ion, hydroxide ion as the only anion, then that substance is called as base. Clear? Some compounds are seen to have H plus as the basic radical in their molecules. These are all acids. Some compounds are seen to have OH minus ion as acidic radical in their molecule, and all these compounds are bases. Those ionic compounds which have a basic radical other than H plus ion and an acidic radical other than OH ion are called as salts. So for example, NaCl is a salt. So NaCl aqueous solution will contain Na plus as basic radical and Cl minus as acidic radical. So NaCl neither contains H plus ion nor it contains OH ions. So the ionic compound which have basic radical other than H plus. So here basic radical is Na plus and it salts also contain acidic radical other than OH ion. So acidic radical in NaCl is Cl minus chloride ion. So it is other than OH ion, isn't it? So salts contain basic radical other than H plus ion and acidic radical other than OH ions are called as salts. For example, NaCl, sodium chloride, calcium nitrate, CaNO3 by 2, potassium sulfate K2SO4, calcium chloride CaCl2, ammonium sulfate NH4 by 2SO4. So I think you have all understood the definitions of acids, bases and salts.